Hello, today we're going to be covering day 2 of 7.8, which is on factoring polynomials completely. Our essential question for today is how can you factor a polynomial completely? We're going to be focusing on some applications of factoring polynomials. In this example, we have a gift bag shaped like a rectangular prism, and it has a volume of 1,152 cubic inches. The dimensions of the gift bag in terms of its width are shown. The height is greater than the width. What are the dimensions of the gift bag? Well, they tell me that the volume of this gift bag is 1,152. I know what the volume of a prism is, and that's just length times width times height. So in this case, my volume is 1,152, and that's equal to the length, which is 2w plus 4, times the width, which is w, times the height, which is 18 minus w. Now, in order to solve a polynomial in factored form, I do need a 0 on one side. But when I subtract the 1,152, this polynomial won't be factored anymore because I'm going to have a minus 1,152 at the end of the polynomial. So what I need to do is actually multiply this right side out, subtract my 1,152, and refactor the polynomial. So I'm going to start by doing that. I'll go ahead and start by distributing this w in the middle. So that gives me 2w plus 4. W times 18 is 18w. W times negative w is minus w squared, equal to 1,152. I then continue distributing this first factor to the second. 2w times 18w is 36w squared. 2w times negative w squared is negative 2w to the third power. 4 times 18 is going to be 72, and then w. 4 times negative w squared is negative 4w squared. All this is equal to 1,152. Now I can simplify by combining like terms on the right. So 1,152 is equal to 36 minus 4 is 32w squared minus 2w cubed plus 72w. Since I want this in standard form, I'll go ahead and start with my highest exponent, which is a negative 2w cubed. I then have a positive 32w plus 72w. And all that is equal to 1,152. Okay, so on the right-hand side, I have a polynomial that I can factor. On the left, I need this to be 0, so now I subtract the 1,152 so that I have a 0 on the left-hand side of my polynomial. 0 equals negative 2w to the third plus 32w squared plus 72w minus 1,152. Now that I have a 0, I will factor that right-hand side. I do need the GCF first, so I take out a negative 2, and I'm left with w cubed minus 16w squared minus 36w minus, factoring out a 2 from 1,152. Since it's a negative 2, I have a positive. 1,152 divided by 2 is 576. And then I factor inside the parentheses by grouping. So I'm just going to focus inside the parentheses. I take out a w squared, and I'm left with w minus 16. On the left, I take out a 36, and I'm left with, I'll take out a negative 36 actually. And I'm left with w, and 576 divided by 36 leaves me with a negative 16. So I have w squared minus, I've got w minus 16 that I can factor out as a GCF, and that leaves me with w squared minus 36. All of this has a negative 2 as my leading coefficient. Now I look at each of these pieces and I see that this w minus 36 can actually be factored further because it is the difference of squares. So I'm going to go ahead and erase to clear myself some space so that I can continue factoring. If you need any more time on this slide, make sure that you pause the video. So bringing this up to the top, I've got 0 equals negative 2w minus 16 times w squared minus 36. Now that w squared minus 36 is the difference of squares. W squared minus something squared, that something would be a 6. So I can factor w squared minus 36 into w plus 6 and w minus 6. Everything else on the front stays the same. So now I have 3 factors that I can't break down any further, and each one with a w, if it is equal to 0, will cause the entire polynomial to equal 0. So I look for each factor with a w, and I write an equation setting that factor equal to 0. Solving each of these, I find that w could equal positive 16, w could equal negative 6, or w could equal positive 6. So I have 3 answers. Going back to our question, these answers are representing solutions for the dimensions of this bag. They do tell us that the height is greater than the width. Notice here that the width is w. So none of my w's could be negative. That excludes this value of negative 6 from our possible solutions. I have 2 other positive values though, so we need to decide which one, or maybe both, are our possible solutions. They tell us that the height is greater than the width, so if my height is 18 minus w and my width is w, I'm going to plug in each of these values to make sure that this height is greater than the width. So if my w is 16, then my height would be 18 minus 16, which is 2, and my width would be 16. Well, that value of w makes my height 2 and my width 16, which means the height is less than the width, which is a problem, because it's supposed to be greater. So that value of w cannot be one of our solutions, which means that w equals 6 is probably a solution. So quickly I'll check. My height would be 18 minus 6, which is 12. My width, w, would equal just 6. Therefore, my height is greater than the width, so I will settle on that solution. The dimensions of my bag then, the width is w, which would be 6 inches. My length is equal to 2w plus 4, which is equal to 2 times 6 plus 4. 12 plus 4 is 16 inches. And my height is 18 minus w, or 18 minus 6, which is 12 inches. So I have found the 3 dimensions of my gift bag. In our second example, I have the width of a box in the shape of a rectangular prism, and the width is 4 inches more than the height, and the length is the difference of 9 inches and the height. I'll go ahead and draw this out. A rectangular prism means that all the faces are rectangles. So I have a shape something like that. The width is 4 inches more than the height, which is h. So my height is h, and the width is going to be 4 inches more, so h plus 4. The length is the difference of 9 and the height. So we write a polynomial that represents the volume of the box. Volume is length times width times height, So volume is h times 9 minus h times h plus 4. Now that I have a formula for volume, I can answer the question that they give me. The volume is 180, so 180 is equal to h times 9 minus h times h plus 4. Go ahead and pause the video and take a moment to try and finish this question on your own. I'll start by distributing my h. 9h minus h squared, and then I need to multiply that by h plus 4. So I continue distributing. My 9h to h gives me 9h squared. 9h to 4 gives me plus 36h. Negative h squared times h is negative h to the third, and negative h squared times 4 is minus 4h squared. All of that's equal to 180. Putting the right-hand side in standard form, I start with my highest exponent, negative h squared. Combining my h squareds, I end up with positive 5h squared, and then I have a positive 36h. All of that's equal to 180. Subtracting my 180 to go ahead and get 0 on one side, I then have 0 equals negative h to the third plus 5h squared plus 36h minus 180. And I need to factor. I start by taking out my GCF, negative 1, and I'm left with h to the third minus 5h squared minus 36h plus 180. Focusing only on inside these parentheses, the left-hand side I take out an h squared and I'm left with h minus 5. The right-hand side I take out a negative and the common factor is 36, leaving me with h. I took out a negative, so this becomes negative, and 180 divided by 36 is 5. So then my GCF is h minus 5, leaving me with h squared minus 36. My coefficient in the front is negative 1, and we are equal to 0. Now from here, I do see that I have a difference of squares that I can continue factoring. This is h squared minus 6 squared, which factors into h plus 6 and h minus 6. I still have that h minus 5 and the negative 1 equaling to 0. At this point, I set every factor containing an h equal to 0, so h minus 5 could equal 0, h plus 6 could equal 0, or h minus 6 could equal 0. This means that h could equal positive 5, h could equal negative 6, or h could equal positive 6. Now looking back up to my picture, h is one of my dimensions, which means that it cannot be negative. So it is not possible for h to be negative 6. My two other options, though, since there are no other restrictions, I'm just asked to find the possible dimensions of the box, are that my height could be 5 inches or 6 inches. From there, I can go back and plug these values in to identify the length and the width. My length is 9 minus h, and my width is h plus 4. So length is 9 minus h, and width is h plus 4. If my height is 5 inches, then my length is 9 minus 5, which is 4. If my length is 5, then my width is 5 plus 4, which is 9. So one of my options is the height is 5 inches, the length is 4 inches, and the width is 9 inches. Option 2, if my height is 6 inches, then my length is 9 minus 6, which is 3, and my width is 6 plus 4, which is 10. So if my height is 6 inches, then my width is 10 inches, and my length is, over here on the left, 3 inches. That brings us to the end for today. Thanks so much for watching, and have a great rest of your day.